Juan, good morning. Can you hear me?
Yes, perfectly.
Yes. Hi, good
Okay.
morning.
Can you please tell me if you are receiving me correctly?
Yes, I
Perfect.
am on my side. So we're waiting a couple more minutes for other colleagues to join us, and then I will briefly introduce you and give you the floor.
Fantastic. I will leave the slide on screen if there's no problem. So
Perfect.
perfect. Thank you.
Sure. Okay, so I think that we should start as it is 10:30. Hello everyone. My name is Luisa Bunescu, and I am the program coordinator of the Higher Education Initiative, HEI Initiative. And this morning, I have the pleasure to introduce to you Juan Herrera Herbert, who's professor at Universidad Politécnica de Madrid and who's working together with the EIT Raw Materials on the CDIO II Project. CDIO stands for Conceive, Design, Implement, and Operate. So without further ado, Juan, the floor is yours.
Thank you, Luisa. Good morning to all of you. Thank you for being there and for attending my short presentation. As Luisa mentioned, I am a mining engineer working at Technical University of Madrid at the School of Mines. And I am going to talk to you about a project that already ended, but not the results ended. We are still enjoying with the results of the project and improving them, but the project ended in 2020 as the funding period of the project. And I would like to highlight that this project is an example first of innovation, because as I will mention later, the CDIO methodology is widely extended in the industrial context, but it wasn't extended in a specific part, which was the raw material sector. And I will explain why. And probably I would like to start by the end of my presentation. This project is an example that when talking about innovation and innovation in education and merging entrepreneurial education with innovation, etc., you never know where you will end. So this is an example of where we didn't know where we were going to end at the beginning. And the best thing you can do is be aware that you will enjoy the travel if you get on board. And that's what happened with us. We enjoyed the travel because we never thought that we will get so far at the beginning and that the results would be so interesting, at least for training and education for new generation of engineers. The next slide, sorry. The CDIO II project stands for, the correct title of the project is Implementing the CDIO methodology, which stands for Conceive, Design, Implement, and Operate, in the raw materials sector. CDI2 stands for the second project because it was the continuation of a first project that took place between 2016 and 2017. And the origin of this project is, as I mentioned before, because the CDIO methodology wasn't present in raw materials disciplines, I mean, bachelor degrees and master programs in the European context. It was widely known and widely applied in the industrial context, but not specifically in raw materials, which stands for exploration, mining, mineral processing, and metallurgy. This first part of primary sector of the raw materials value chain wasn't, the CDIO methodology wasn't applied. The consortium that took ahead this project was constituted, you have them on screen, by alphabetical order, by Chalmers University of Technology, Luleå University of Technology in Sweden, LKB, which is the main iron producer in Europe, RWTH Aachen from Germany, the Research Institute of Sweden, and the Technical University of Madrid from Spain, and the University of Limerick from Ireland. And this project took place immediately after the ending of the CDIO I, which so it started by 2018 and ended in June 2020. So it ended some years ago, but as I mentioned before, we continue working on the results and taking advantage of the results and improving the results that we had on the project, especially in the field of the innovative labs applied to education. For those who are not familiar with the CDIO methodology, the CDIO methodology is the idea to train the students in four main aspects: conceive, design, implement, and operate, which means trying to develop new products, new solutions that can bring answers, and train the students to be able to conceive them as understanding where are the needs, to design them by making them familiar with the process of drawing and creating the new algorithms, to implement, which means put in place the construction of this new solution, and to operate later this new solution. And for this, the CDIO methodology includes four main aspects, which are common aspects related to this methodology. First of all, a curriculum organized around mutually supporting courses. Second, a rich design, build, and test project inside the curriculum. Integrating learning of professional skills, which means training the students to be familiar with teamwork and communication, and not only familiar, but develop them to be absolutely, let's say, sorry, I forgot the word, to train them to be fluent in that, in those skills. Second, or in fourth case, try to build inside, well, bring a strong experiential learning inside the program, not only have the students attending lectures, but participating inside the development of a project that will bring the learning outcomes to the students. And by the end, this has to be something that you learn from experience, so you need to have a constantly quality assurance process inside the project. So CDIO methodology tends to create this new generation of engineers that will have the responsibility of creating this new future. No, to change the world, you need to be taught differently. This is the structure behind the CDIO methodology. Okay, the CDIO project was developed by a consortium with most of the partners that were participating. Not all the partners continued in the CDIO II methodology, but all the universities, except in Delft, continued in CDIO II, mostly because all of us were involved in raw materials, in the primary raw materials, not in secondary raw materials in the other case. But the first attempt of the CDIO methodology, which raised the interest of EIT Raw Materials, and that's why they decided to fund this project, was that by 2015, it was clear that in Europe, in the European landscape of education, there were no universities applying this methodology in their academic programs. And what it was clear is that to teach innovation, you needed to teach differently. So CDIO methodology was bringing a good opportunity to improve the creativity and the innovative skills to our students. Merging this CDIO methodology with entrepreneurial skills was the object of this CDIO I project. We need to explore how we were going to do it, and that was the object of this CDIO I. With that experience, we created CDIO II, which was a project oriented to implement from a practical point of view all what we learn. While in CDIO I, we had to learn how to do it, and most part of the project was intended to train staff, train lecturers. Now there was one part oriented to continue training the universities, but start training students and going ahead with this practical part of the training. So the first question was that we needed more T-shaped students. That was something critical for EIT Raw Materials Academy, who was funding the project. We needed to improve the number of T-shaped students, and this project was one opportunity to do that. On second stage, we needed to demonstrate that with this methodology, we could increase the knowledge of particularly students in mining exploration, mining technologies, metallurgy, and mineral processing, and make them more entrepreneur-oriented students. No? So for that, we needed to create a unique combination of practical and technical content. So the idea was to change the educational programs that were behind. And for that, we needed the support also from this industry, because we needed to have a direct and very quick feedback from industry to know if we were in the right direction and if what we were trying to teach to the students was what they really needed. So we needed this direct feedback from research and from industry. That's why industry and research were present in the project. This slide that you have on screen is somehow the vision of what is a T-shaped professional, specifically in the raw material sector, and particularly in the primary raw material sector. Together with this idea behind, we started developing CDIO II project. So as I mentioned, one of the main objectives was to continue developing the faculty. We organized inside the course plenty of inspirational lectures and workshops oriented to train the staff of the different universities. But the second part of the project, and what probably the most important, that's what we discovered at the end, was the creation of something that didn't exist really at the beginning, which were the educational innovative labs. I mean, innovative labs are widely used by industry to develop new products, but very, very few universities use them as a training tool for students. So we decided to create inside our universities innovative labs oriented to raw material sector and enabled that as a way to create somehow an improvement and a modernization of our studies and making them more practical and more oriented to business, more oriented to entrepreneurship and to intra-entrepreneurship. Together with that, and with all that experience, we decided also to create some common project courses. I mean, some common courses given by the whole the universities participating in the consortium. No? And by developing the innovative, educational innovative labs and this common course, we were sure, we demonstrated at the end that the students participating in the experience would improve and really improve of their communications and their teamwork skills. I would like to pay some attention to what was the educational innovative labs, which is a concept that didn't exist in the raw material sector, at least in education. And we started creating these facilities at the Technical University of Madrid. We created at educational innovative labs for mine ventilation, which has been internationally recognized since then. And we are improving the mine ventilation studies by the use of this innovative lab, particularly in the master level students studies. Just a quick view on which were the work packages that behind this project. As work package, we had four. We divided the project in four work packages, oriented to focus in these four main objectives of the project. And when talking about the innovative, the educational innovation or innovative labs, the idea was to bring to education something that is now common in industry, something that allows industry to foster innovation and foster the creation of new products, but also new practices in-house. No? We decided to bring this experience to education. And with the results of this creation, as I will show later, we think that we had a good solution to implement the CDIO methodology on a very practical and business-oriented training for students. The idea was to bring that experience that already exists on industries, but differently. I mean, an educational innovative lab is at the end very different from what is a common industry innovative lab. I mean, or as it is used by industry. While in industry is used for a very specific purpose, which is creation of new products or creation of a new process or creation of a new system inside the industry. For universities, the objective is to train the students, to help students to achieve those skills that they will need to be really creative and innovative when developing their professional activities. So what we created was an ecosystem inside the universities that made a replication of what is a real innovative lab on industry with the help of industry, and give the students problems that were posed by industry and train them and see how they find solutions. The finality of this project is to show students how it works, to show students how innovation happens, and make them feel safe when starting developing ideas, and at the same time allow them to get confident on their skills and their capacities. And at the end, I mean, it's not important if they get a good solution or not for a problem that is provided by industry, because the objective is not to get a good solution or a good result. The objective is to make them understand that when finding solutions to real problems, solutions are not so easy as initially they could find it where they were, because they have to face many and very different complex aspects when facing those problems. At the end, which were the results? Well, some results that we found and that were published as a result of this project were that first, those innovative labs that we created really foster creativity, because students have no pressure on if the result is good or not. So they started dreaming even solutions, dreaming answer and testing them, and they found which were really crazy solutions and which were apparently interesting. The objective was to introduce the students to the culture of innovation from a practical point of view, not to tell them innovation is important or what they need to know to be innovative. No, make them work on this aspect and get by themselves those skills. So it was a real learning by doing environment, what we created. And at the end, it's not a showcase labs as many educational labs that we have in universities, where professors and lecturers make demonstrations and students attend the lectures and probably make some experiments that were already designed by the professor, so the result is predictable. Here, there's no predictable result. They have to bring up their crazy ideas, test them, and see where they get. No? The idea, as I mentioned before, is it will not provide any real innovations. I mean, we found good ideas. Even some ideas were applied later by industry or by us at the universities. But the objective wasn't to get good ideas. The objective was to train the students, to show them the way. And on that basis, these are not research or development labs. No, it's just a facility to have the students training, which is completely different as what is intended for a research lab. So some conclusions of this experience is that by the end, all of us who participated, we somehow knew it, but we finally got convinced that if we needed to train the new generations of engineers that will have to work differently, we are facing a radical digital revolution, and students will have to work in that environment. We needed to train them differently. and we needed to bring to them new skills and a much wider knowledge than what is in the conventional academic programs in universities. Innovative labs demonstrated to us that they were a very good solution to complement the normal training that students are following in their academic programs. I mean, it was the results. The results were for us so interesting that we have been continuing with these innovative labs, at least here at the School of Mines, and we have particularly a particular training, which is in mine ventilation and mining development. We widely use these innovative labs just to teach and just to train the students in these new skills that they will need in this new era that is the 21st century. So with this, I expect not to be have been too long in my explanations, but I appreciate your attention, and I'm open for questions if there are any questions. And thank you. I really appreciate the opportunity of explaining what we did with this project and obviously your attention.
Thank you very much, Juan. It was a wonderful presentation, and myself, I learned a lot from it. So, colleagues, if there are any questions, we still have a couple more minutes until we move to the next session. So, please feel free to write down in the chat or in the Q&A your questions. We will be happy to take them up. What we have. We have a question from Anne-Marie. She's asking, what would you say was the biggest challenge for you, I suppose, when implementing this project? Juan, are you... Thanks, Anne-Marie. Juan, are you still with us? Okay, I think we lost Juan, at least temporarily. I'm very sorry for that. Juan, can you hear us? Yes, you're
I'm
back.
back. Sorry. When I stopped sharing my screen, I was fully disconnected from the system. Sorry for that.
Yes. So if you can briefly, if you would briefly reflect on Anne-Marie's question, what was the biggest challenge for you when running the project? And then we conclude with this, I suppose.
The biggest challenge was creating something new. I mean, creating an innovative lab when we didn't really know what it meant, no? And try to explain to our rectorate that we wanted to spend some money in creating something that we couldn't really explain which were the objectives. I mean, it's somehow challenging, at the beginning. But at the end, I think we demonstrated that we were so enthusiastic in creating these innovative labs that they believed on us, and we had room enough to create this innovative lab and start testing them. And I guess that the results were positive. No? So probably the most challenging aspect is something related with innovation. Try to explain that you are going to do something that doesn't exist and convince others that you are going to do it. No? And so part of the training on innovation also felt on us. We started by experiencing what means being innovative, which is you have to explain that you are going to do something that doesn't exist, and you need somebody else to believe on you. So that's challenging.
Thank you very much, Juan. I think one of the key takeaways, if I can sum it up, is that the commitment of top leadership at higher education institutions is essential. And to me, this morning you made a very good case on the importance of learning and teaching, and more precisely on the importance of curriculum design to advance a different way of teaching, especially when it comes to entrepreneurship and innovation. And there was a quote that stayed with me from one of your slides that says, to change the world, you have to be taught differently. And I dare to say you would have to teach differently. So thank you very much for clearly making this case this morning. And thank you to all the colleagues that attended this session. So the next one will start at 11, and we invite you to then go to the other virtual rooms now. Thank you very much, and thank you, Juan, once again.
Thank you
Bye.
very much to EIT.